Hello my dear students, welcome to my channel Fluid Mechanics Lecture Series. I am your SumamMiss. My channel name is also SumamMiss. You can watch my videos on my channel. If you found useful, please don't forget to like, share, comment and subscribe. I am just awaiting your comments. The topic for today's discussion is action of fluid pressure on a surface. Before starting the discussion, I introduce two terms. One is total pressure and other is center of pressure. Total pressure on a surface is the force exerted by the static mass of fluid on a plane surface when the surface comes in contact with the fluid. It always acts in a direction normal to the surface as there is no shear force in static mass of fluid. Total pressure is also termed as hydrostatic force. The point of action of total pressure on an immersed surface is called center of pressure. Why these two terms are important? The knowledge of magnitude, direction and location of this resultant hydrostatic force on a submerged surface under liquid is very much essential in the design of locks, gates and dams and in all water retaining structures. In a body of fluid, pressure may vary from point to point as the pressure at any point depends upon its position with respect to the free surface. So pressure increases when we move down. So consider the pressure forces acting on this element. So P1 into delta A1, that is the pressure force acting on this element, where P1 is the intensity of the pressure and delta A1 is the area of this small element. Similarly, P2 delta A2, that is the pressure force that is acting on this element. If the fluid pressure acts on a surface, all the pressure forces acting on the small elements can be represented by a single force that is called resultant force. If the surface is plane, all the pressure forces acting on the small elements will be parallel and perpendicular to the surface. So the resultant force also perpendicular to the surface and it is acting through a point that is called center of pressure. So resultant force can be represented by sigma P into delta A. Consider a curved container holds a liquid. You can see this type of containers in the case of water tanks, petroleum tanks, etc. So in the curved surface, the pressure forces acting perpendicular to the surface and will therefore not be in parallel. So the resultant force can be obtained by the resolution of these forces and it is less than sigma P into delta A. Extreme case is the curved surface of the bucket which filled with water. So this is a cross section of this bucket. Here the elementary forces are acting radially on the vertical wall of the bucket will balance and the resultant force equal to 0. But it doesn't mean that the force on the wall of the container equal to 0. So if you want to find out the effect of the pressure, we need to consider half of the container and find out the forces on the wall. Now let us consider a horizontal plane which is immersed in water. Pressure in a plane horizontal surface immersed in static mass of fluid is same at all points. Consider a point at a distance of h from the free surface. So pressure at this point equal to rho gh. So based on the Pascal's law, intensity of the pressure at any point in static mass of fluid is equal in all directions. This plane is equidistant from the free surface. So the pressure at the point D and pressure at the point B and pressure at the point C, that is equal to rho gh. So it is equal to gamma h. Specific weight rho g, that is also represented by the notation gamma. So the total pressure that is acting equal to intensity of the pressure at a point multiplied with the total area of this plane. So that is equal to gamma h into area, or it is equal to rho g into A into h bar. Since this plane is horizontal and pressure at every point in this horizontal plane is same, then we can write the expression for total pressure as P equal to rho g into A into h bar, where h bar is the center of gravity of this plane with respect to the free surface. since the pressure in a plane horizontal surface immersed in static mass of fluid is same at all points, the total pressure that is acting through the point which is coinciding with the center of gravity of this plane. So center of pressure here equal to HP equal to H bar, where H bar equal to H. In the case of vertical plane, which is immersed in water, pressure at every point is varying because pressure at any point depends upon its position with respect to the free surface. So if you are moving the point under consideration from top to bottom, pressure increases. Now this point which indicates the center of gravity of this plane with respect to the free surface. Since the pressure is varying from point to point and it increases when we moves down, unlike in the horizontal plane, total pressure is not acting through the center of gravity of the plane, but it is acting through a point which is located below the center of gravity. So H bar represents the center of gravity of this plane with respect to the free surface, whereas HP indicates the location of the center of pressure with respect to the free surface. Now consider a point Q on this vertical plane. So it is at a distance of h from the free surface. Now dA is the area of this small element. So intensity of the pressure at this point equal to rho gh, or the pressure forces that is acting on this element equal to rho gh into delta A. If the fluid pressure acts on a surface, all the pressure forces on the small elements can be represented by a single force called resultant force. So the total pressure force can be represented as P equal to integral of dP. So what is dP? dP equal to rho gh into delta A. So integral of dP can be replaced as P equal to rho g into integral of h into dA. So dA into h represents moment of this area about this free surface, and integral of delta A represents the total area of the surface. So integral of h into dA represents moment of this total area about this free water surface, or it can be represented as A into h bar. Or in other words, the total pressure force equal to P equal to rho g into A into h bar. So since the pressure increases when we move down, unlike horizontal plane, center of pressure is not coinciding with the center of gravity, but it is acting at a point which is below the center of gravity. So in order to find out the center of pressure, we have to apply the principle of moments. So the location of the center of pressure can be determined by applying principle of moments or Varigan's principle. So principle of moments states that sum of the moments of resultant force about any axis equal to sum of the moment of the component forces about the same axis. So if you are taking the moment of this pressure force on this element about the free water surface, that is equal to delta P into H. So what is delta P? Delta P is the pressure force acting on the small element. So delta P equal to rho gh, that is the intensity of the pressure, multiplied with the area of the small element will give you the pressure force acting on the small element into H. So we can write this expression as rho g into delta A into H square. Sum of the moment of all such pressure forces about the free surface can be written as integral of rho g into delta A into H square. Delta A into H represents the first moment of area about the free surface, whereas delta A into H square represents second moment of area about this free surface. In other words, integral of delta A into H square represents the moment of inertia of this plane about the free surface, or it can be represented as rho g into I naught. So I naught is the moment of inertia of this plane about this free surface. Now, based on parallel axis theorem, I naught can be written as Ig plus A into h bar square, where Ig is the moment of inertia of this plane about an axis which is passing through the center of gravity. Then A means that is the area of the plane, and h bar is the distance of the center of gravity with respect to the free surface. Since the pressure may vary from point to point, and the pressure increases when we move down. So total pressure force that is acting perpendicular to the surface through a point that is called center of pressure. Now, based on the principle of moments, moment of the resultant force about this free water surface can be written as P into HP. So P is the total pressure force. So we have learned previously that total pressure force equal to rho G into A into H bar, where A is the total area of plane and H bar is the distance of the center of gravity with respect to the free surface. So moment of total pressure force about the water surface equal to rho G into H bar into HP, and it is equal to the sum of the moment of all such pressure forces about the free water surface, that is rho G into I naught. If we are replacing I naught by Ig plus A into H bar square, then we can write the expression for HP as HP equal to I naught by AH bar, or it is equal to H bar plus Ig by AH bar. So in the case of vertical plane which is immersed in water, the center of pressure equal to H bar plus Ig by AH bar. Ig is the moment of inertia of this plane about an axis which is passing through the center of gravity, whereas A is the area of this plane and H bar is the distance of the center of gravity from the free surface. Now let us discuss about the action of fluid pressure on an inclined plane immersed in water. So consider an inclined plane which is inclined by an angle theta with respect to the free surface. Consider a point Q which is at a distance of h from the free surface. Now center of gravity of this plane is at a distance of h bar from the free surface, and center of pressure that is acting at a distance of hp from the free surface. Now how will you calculate the total pressure force? So in order to find out the total pressure force, we have to assume an axis OO which is perpendicular to this inclined plane. So with respect to this axis OO, this plane is vertical. With respect to this axis OO, the position of Q, center of gravity and center of pressure is marked as Y, Y bar and YP. Now pressure intensity at this point Q can be written as pressure intensity equal to Q equal to rho GH. The pressure force that is acting on this element with area delta A equal to rho GH into delta A. H can be written as Y sin theta. So delta P can be written as delta P equal to rho G into H is replaced by Y sin theta into delta A. If the fluid pressure acts on a surface, all the pressure forces acting on the small elements can be represented by a single force, that is called a resultant force. So total pressure force acting on this inclined plane equal to P equal to integral of dP, or it is equal to P equal to rho G sin theta into integral of Y into dA. So dA into Y, which represents moment of the small area about this axis OO, and integral of dA represents the area of this entire plane. So integral of Y into delta A represents the moment of this total area about the axis OO. Integral of Y into delta A is replaced by A into Y bar, where A is the total area of this plane and Y bar is the distance of the center of gravity with respect to this axis OO. Now what is this Y bar sin theta? Y bar sin theta means it is H bar. So this expression is rewritten as P equal to rho G into A into H bar. The expression for total pressure for a horizontal plane and vertical plane and inclined plane immersed in static mass of fluid is same as P equal to rho G into A into H bar. So in order to find out the center of pressure for a inclined plane, again we have to apply the principle of moments. So principle of moments states that sum of the moment of resultant force about any axis equal to sum of the moment of the components about the same axis. So consider the moment of the pressure force about the axis OO. So it is equal to dP into Y. So dP equal to rho GH into delta A. So rho GH is the intensity of the pressure at this point. Multiplied with the delta A will give you the pressure force multiplied with Y. y is the distance of this element from this axis OO. Again, we replace h by means of h equal to y sin theta. So this expression is equal to rho g into h is now replaced by y sin theta into delta A into y. So it can be written as delta m equal to rho g into delta A into sin theta into y square. Sum of the moment of this all such pressure forces equal to m equal to integral of dm. So it can be written as m equal to rho g sin theta that we have taken outside into integral of y square delta A. So we have learned previously that integral of y square delta A represents second moment of area about the axis OO, or it is called moment of inertia of this plane about this axis OO, or it can be written as rho g sin theta into I naught. So I naught is the moment of inertia of this plane about this axis OO, and based on this parallel axis theorem, I naught can be written as Ig plus A y bar square, where Ig is the moment of inertia of this plane about the axis passing through the center of gravity, and y bar is the distance of center of gravity from the axis OO. Now, moment of the resultant force about this axis OO equal to P into Yp. So what is P? P is the total pressure equal to rho g into A into h bar into Yp. Now based on the principle of moments, rho g into A into h bar into Yp, that is equal to sum of the moment of all such component pressure forces equal to rho g into sin theta into I naught. Now what is Yp? Yp can be written as hp by sin theta. So if you are substituting the value of Yp by means of hp by sin theta and replace I naught by means of Ig plus A y bar square, then you will get an expression for hp like this, and by simplifying this expression we can write hp equal to Ig sin square theta by Ah bar plus h bar. So Ig is the moment of inertia of this plane about an axis passing through the center of gravity. H bar is the distance of this center of gravity with respect to the free surface, and A is the area of this plane. So center of pressure for an inclined plane can be written as hp equal to Ig sin square theta by Ah bar plus h bar. So if theta equal to 0, sin 0, that is equal to 0, so this term will disappear. So hp equal to h bar. If theta equal to 0, that means plane is horizontal. So your center of pressure that is passing through the center of gravity of this plane. If theta equal to 90 degree, sin 90, that is equal to 1, or the plane is vertical, we can write hp equal to h bar plus Ig by Ah bar. This is the same expression obtained in the case of vertical plane immersed in liquid. So to conclude, the expression for total pressure is same for horizontal plane and vertical plane and inclined plane immersed in static mass of fluid is same, and it is equal to P equal to rho g into A into h bar, whereas the expression for center of pressure is different for horizontal plane and vertical plane as well as for inclined plane. To conclude, one can say that the expression for total pressure and center pressure is very much essential in the design of gates, locks, dams, and in all water retaining structures. Now the session comes to an end. For the time being it is enough. Thank you. Awaiting your comments. Next videos on pressure force on immersed curved surface and pressure diagrams. Please don't forget to drop the comments. Please don't forget to press the bell button to get the notification of forthcoming videos. With that, thank you.